Here today with John Heltzel, AIA from Virginia, and we're excited, John. We've done a bunch of projects together over the years and have a long, lasting relationship. Today we're talking about industrial work. Everybody's excited about onshoring in the U.S. and
Hmm.
manufacturing, and so in the design and construction industry, we're thinking about what are the best buildings to build, what are the best design features and structures. So, John, when a client comes to you and wants to do an industrial project, where's your mind going on design?
Well, yeah, I think probably the first thing is what we were kicking around earlier, the term of long span. Usually that's sort of hand in hand with industrial. But we also first ask, does it truly need to be long span? Maybe it just needs to be big, right? It needs to be big, open space. But does it need to be clear span so there's no center columns anywhere for 60, 80, 100, 200 feet, 500 feet? Can you tolerate columns? It makes a huge difference in strategy for design and generally in cost once you get into buildings that are, let's say, over 100, 120 feet. Those center columns mean money or not. So that's one of the first things we would address.
So, educate me on a typical block, joist, and deck project. What's your typical span that you can go without columns or column to column?
If you can work within 25, 30, 35-foot increments in a structural grid, you are the most cost-effective grid. But maybe that doesn't work, right? We got big racks, we got forklifts, we got trucks coming and going. Can't do that. So now, if we're, let's say, 60 feet, we're still working off stuff probably right out of the steel yard. We're going over 60 feet. Nah, we would classify that as long span. Now we're getting this a little bit more exotic materials. Especially, going to have to wait to get delivery, have them fabricated. So 60 and on is sort of that threshold. But now the difference between 80 and 150, we're still talking about the same language.
So, when you're talking about exotic materials and different things, what are the systems you're talking about? What materials you're thinking about designing?
Well, I think when I loosely use the term exotic would be basically not something that's already out there in the yard ready to go. We're gonna have to get some engineered a little more specifically. Patients about okay, what's our tolerance for these depths now? So we're going 130 feet. No problem, but what kind of equipment are we putting in there? How high are our racks? What kind of do we put a crane system in like behind me? Now we're starting to think about the depths of those structures, and the more compact we make them, yet still the same span, the more expensive it's going to
Right.
become.
So, when I think of it, the systems, I'm thinking, traditional joist and deck, then, pre-engineered metal buildings, some tilt up joists. Of course, tilt up, you still need some columns too, right? But is there anything I'm missing there?
I think those are the top few on the menu. You can get into more complex systems where you truly need it, right? If we're building a stadium or a large marine facility or something like that that has some unique requirements, then you can get into fabric structures, things like that can span two football fields,
Right.
right? We're probably not talking about that, but yeah. So I think the main ones you're always going to be right at the top of the list are going to be your conventional steel framing, bar joists, and steel beams, steel girders, pre-engineered, great option, and in some cases even a combination of the two. Like for longer spans, 60 to 200, 250, 300. Steel's going to be the way to go. Now, and not to, the the little sister of wood, don't necessarily want to discount that. If you're doing, let's say, a building that's 60, 80 feet, maybe 100 feet, don't throw out wood because wood's still pretty darn cost effective. Now there's some downsides, obviously, but you don't want to throw that one out just yet. Now we're getting into 150, 200, we're done.
So wood is like a glulam member?
No, I think for longer spans, you're going to do some sort of truss, whether
Okay.
it's like a parallel truss, so the roof is flat, the ceiling's flat, and they're parallel. But
Yeah,
you could do like your house, right?
yeah,
A pitched or some sort of combination. Wood's still a good option for some.
I got you. So if you had to pick like your go-to, what you would just run and design for a long span system, what do you have like something that you feel your favorite, or do you always want to defer to the structural engineer and get various pricings on the different options?
Now, I think the first thing we would do, just like almost any major building component, is let's establish some basic criteria. What are the top three, four, five things that are going to influence that decision? So when we're talking about more industrial or large span, bigger buildings, first couple things I'm going to ask right in the first 10 minutes of the meeting is, well, what are you putting inside of it? Right? So if it's an airplane hangar, you're going to put an airplane in, that's different than if it's going to be a sanctuary, right? Because of the tolerances for movement and sound and deflection, water leaking. How bad is it if it leaks? Those types of things. Very first thing. What are we putting inside? Second one is, are we going to take advantage of the roof structure for anything else other than keeping the rain and the sun out? So for a data center, we're going to put a farm of cooling units up there, right? So now it's going to be carrying stuff in addition to just snow loads and people up there servicing equipment. So now we got to be concerned about maintenance, getting up there to move around and to fix these things. So what are we going to do? Do we need to do anything? Do we need to put anything on top of this roof? That's the second big one. Third one is just the aesthetics, right? So if we've got this particular site has some proffers, and it says, well, we can't do a pre-engineered metal building. For better or worse, somebody wrote that in a proffer 10 years ago. So I got to check that and see, is there an architectural review board, something like that, that says you got to do this or that. So once we collect all that stuff, then we're going to make the decisions. And frequently, it is going to come down to two. It's going to be either pre-engineered or it's going to be conventional steel bar joists and girders, maybe columns, maybe not, depending on budget and clear span. 90% of them in the world that we're talking about right now, it's going to come down to one of those two.
Yeah. Well, that makes sense. That definitely makes sense. Anything else you can think of that you want to share as far as your design process or thinking?
I think that when we talk about the budgets, when that becomes a factor in making these decisions, once we've established that main criteria that yes, we need to put something on the roof or we don't, when we talk about the cost of these structures, don't necessarily want to look at it from solely the purpose or from the cost of the the structure itself, because there's other things on top of it, right? So if we say, well, we're going to do a bar joist in a metal deck, okay, so the structure is X number of dollars a square foot, but now we've got to do a tapered rigid insulation on top, maybe a TPO roof, a lot more flashing, maybe a parapet. So there's all these other things that come with it that have potentially increased line item costs, as opposed to, let's say we go to a pre-engineered metal building, standing seam or corrugated metal on top of that building. That's kind of the end of the story, right? There's not a whole lot more to it. So it's the actual roof surface, the roofing product that varies too. That's part of the overall cost analysis on this. And again, there's the benefit of one over another as well, where pre-engineered, standing seam, or corrugated, There's a certain lifespan on it, and rivets can tend to pop, and sometimes they condense, so you get a little water in there. So those are all things that should be plugged in when you're sort of doing a cost analysis, in addition to just the steel.
Yeah. Yeah. So in other words, structure is only one component, skin's one component. We need to weigh lifetime benefits. We need to weigh of course, the rest of the divisions. Well,
Yeah.
good. Well, thank you. This has been super helpful. I really appreciate the conversation, John.
Anytime. Love to talk about buildings.
Let's do another one.
All right, sir.
Bye.